Hi, this is Mr. Barr, and this video deals with the homework that goes with expressions 2 for the CASP. So we've got this table here. We've got to fill it in. Remember, it's like Sudoku. So this plus whatever I put there has to equal a 135. So 40 plus 95 is 135. Same thing this way, 95 plus 225 has to equal these things. So going across, it has to equal. Going across has to equal. Going down, it has to equal. Going down, it has to equal. Scatterplot, it says to find the y-intercept and the slope of the line. Well, the y-intercept's right about here. I put it at 75. And then notice it's giving us a perfect triangle right here. The rise of this triangle is 75. There's my rise. The run of this triangle is 6,000. It's negative because it's going downhill. And if I divided that using my calculator, I'd get negative 0.0125. And I'm looking at my answer key, and my answer key looks good. Here's another scatter plot with the best fit line. It says find the y-intercept. Well, the y-intercept's right there at about 20. And it also says what's the slope of it. I draw in a triangle. There's my triangle. I count the rise, which is 10, 20, 30, 40, 50, 60. There's my rise. My run is 30. And I divide that, and it becomes a 2. And that looks good with my answer key. A movie theater has 2 different deals. Figure out when the deals are the same. I started by making a table. So I have movie theater A, where it's just $12 a ticket. So if I go to the movie 0 times would cost $0. Then 1 time would be 12, 2 would 24, 3 is 36, 48. I just make this table. Movie place B, you pay $16 for the pass for the discount card, and then it's $8, $8, $8, $8 for each ticket. It comes together right here at 4 movies. 4 movies would cost $48 in both locations. Next one, solve this system. Both of these were given to you in standard form, which means you need to do move the x, divide by the y before you graph it. So I did move the x, divide by the y, and I got these 2 equations. They're not beautiful, but they're good enough. Now I'm going to graph it. This one starts at negative 2.6. There's negative 2.6 is right there. I'm going to go up 2 over 3, up 1, up 2 over 1, 2, 3. There I am. The other one starts at positive 2.6. There's 1, 2.6. And I go down to 1, 2 over 3, puts me right about there. Now let's connect the dots. And since these were not perfect, we're just going to go with whatever is kind of the closest thing. And the closest thing is right about there. And that's going to be at 1, 2, 3, 4, comma 0. It's the best I've got for you. There are other methods for doing this, but I did not teach them to you because man, this method is going to get you good enough. It's going to get you close enough. So 4, comma 0. Next one, we have a couple cell phones. This one costs $5.50 a month and 5 cents a minute. Company B, no monthly cost, but 7 cents a minute. Both of these are linear. If you were to graph these, like the cost per minute, you would get lines. So they're both linear. And the 2 graphs will not intersect. No, they'll come together somewhere. At some point, this becomes more expensive, right? Company B will always be cheaper. No, if I talk for a couple hours, it's probably going to be more expensive. I could figure out where it becomes more expensive, but I'm not going to. You can only determine which one is cheaper if you know the number of minutes. That's correct. Which one should you buy? What phone? You don't know until you really think about how often you're going to use that phone. If you make one call, If you talk for 1 minute, you should get company B. 10 minutes, company B. 1,000 minutes, I don't know, company A. Okay. Number 7. Number 7 is going to, you could graph it, but as soon as I did move the x divided by the y, I can see that the slopes are different, which means it's going to intersect somewhere. So where does it intersect? Well, then I am going to have to graph this. Let's graph it. I thought I could just be done by just telling you that it does have a solution, but I have to graph it. So here's a graph. And what am I graphing? I'm graphing 3.5 going down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. And the other graph starts at -4 and goes up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. There's the point. That's the point right there. That's where it's all coming together. And that's at 3, 2, which is what I had. Cool, that was number 7. Number 8, a system of 2 linear equations has infinitely many solutions. One equation is right here, 2x minus 3y equals 6. Select the equation that would make this system have infinite solutions. Infinite solutions means it's the exact same equation. So I did move the x divided by the y, and I got y equals 2/3 x minus 2. And I kept doing that for each of these until I found the one that was identical, and it's C. C is also y equals 2/3 x minus 2. Number 9, you know what? Okay, this is not the bonus. This is not the bonus. I'm going to try to mess with you. This is not the bonus. Nope, not the bonus. Not the bonus. Number 9. So if this is 5, I would say that the y-intercept's at either 4.5 or 4. So I've got 2 answers there, 4.5 or 4. And then if you draw in your slope triangle like this, I had 8 over 5, which is about 1.6. But if you went a little bit higher up like that, you'd probably get something closer to a 1.5. So there's a little bit of a wiggle room in that answer. Number 10. I've got to graph it. Number 10. I started by doing move the x divided by the y, and I have these 2 equations. This one starts at 7. 1, 2, 3, 4, 5, 6, 7. I go up to over 1, which is going to take me down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. There we go. This is barely going to fit. The other one starts at -2 and goes suddenly I'm very confused. It goes down 5 over 2. 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. Okay, there it is. That's the point where it all comes together. And where's that at? -2, 3. And it's just asking for the x coordinate. So the answer is just -2. Okay, I've got to fill in this table. So the 94 goes here, the 128 goes there, the 68 goes there, the 154 goes there. So these are all values that I brought over to the table. Then it also says that 74 people don't like tacos and don't like pizza. So no tacos, no pizza. There's the 74. I throw all those numbers in there, and then I do that Sudoku thing. Number 12, I never taught you how to do it, so you're just going to get it wrong. I know that's lame. You can still get an A on the test. I'll I'll take care of it after the fact. Consider this. Markup for true for all, true for some, true for none. Two lines that have different slopes will never intersect. Nope. If you have different slopes, you will always intersect. Two lines that have different slopes will intersect at exactly 1 point. That is true. Two lines with different slopes will always intersect at 1 point. Two lines that have the same slope will intersect at exactly 1 point. Now, same slope is either going to give you infinite or none, but it's never going to give you a 1. And this is the one that's confusing. Two lines that have the same y-intercept intersect at exactly 1 point. Well, here are two pictures. Same y-intercept, 1 point, correct? Two lines. Two lines, same y-intercept, but they're coinciding, infinite points. So this is a sometimes. Sometimes they intersect at 1, sometimes they're infinite. Oh, and now for the real bonus, this is number 13. Are you ready? This is the real bonus. The word for number 13 is tire. Bonus word number 13, tire. Thanks for watching. I know I made you go all the way to the end to see the bonus word. That's it.